Hi everyone! Let me briefly introduce myself. My name is Iryna Bodnar and I am delighted to be here today to talk to you about prediction of cervical cancer. My presentation is divided into 6 parts. I'll start with the main goal and the relevance. Then I will look at analogues and dataset of the project. Next, research methods, and finally, research tools. The main goal of the project is improving of diagnosis of disease in women and the work of doctors in this field. Besides, we can get an immediate diagnosis based on information and analysis of the patient. I'd like to give you some background information about cervical cancer. The average age of women diagnosed with cancer of the cervix is 50. More than one-third of new cervical cancer diagnoses are in women between 20 and 44 years old. About 80% of all cervical cancer diagnoses are in women younger than 65. Although it is the most preventable type of cancer, each year cervical cancer kills about 300,000 women worldwide. That's why my project is relevant now. Turning our attention now to analogues of the project. There are many different systems based on different ML classifiers, such as naive Bayes, Logistic Regression, Lazy-based LWL, Meta-based Iterative Classifier Optimizer, Rule-based Decision Table, and Trace-based Decision Stamp. Graphical have been deployed on the dataset to predicting the stages of the cervical cancer. The comparative analysis of these ML techniques for the prediction of stage for cervical cancer is done on the basis of different analysis parameters, such as true positive rate and false positive rate. To illustrate the point, I show you this slide. Here you can see comparative analysis of system based on ML techniques for cervical cancer stage prediction based on true positive rate and comparative analysis of systems based on F measure. I'd now like to move on to the next part, dataset. There are 36 different indicators that make it possible to evaluate the risk of the disease. The main ones are DX cancer, STDs, number of diagnoses, number of pregnancies, first sexual intercourse, cytology, biopsy. As an illustration, you can see the part of my dataset. Let's now turn to research methods of machine learning. I'd like to expand on this point and to tell you about 3 different algorithms of ML. First one is naive Bayes, based on a plane-based theorem with strong naive independence assumptions between the features, highly scalable, requiring a number of parameters, linear in the number of variables in a learning problem. All naive Bayes classifiers assume that the value of a particular feature is independent of the value of any other feature, given the class variable. The next method is random forest, an ensemble learning method for classification, regression, and other tasks that operate by constructing a multitude of decision trees at training time and outputting the class that is the mode of the classes, classification or mean prediction regression of the individual trees. Random forests are a way of averaging multiple deep decision trees trained on different parts of the same training set with the goal of reducing the variance. This comes at the expense of a small increase in the bias and some loss of interpretability, but generally greatly boost the performance in the final model. The last one is logistic regression. Logistic regression is used when the dependent variable target is categorical. Logistic regression is used in various fields, including machine learning, most medical fields, and social sciences. For example, the trauma and injury severity score, which is widely used to predict mortality in injury patients, was originally developed by Boyd using logistic regression. Many other medical scales used to assess severity of a patient have been developed using logistic regression. Logistic regression may be used to predict the risk of developing a given disease based on observed characteristics of the patient. Let's summarize briefly what we have looked at. In my opinion, one of the best methods is logistic regression because it is widely used in various fields of medicine and gives an accurate and proper result of research. Logistic regression not only gives a measure of how relevant a predictor is, but also its direction of association. Logistic regression is easier to implement, interpret, and very efficient to train. This leads me to my next point, which is research tools. In this point, I like to tell you about advantages of programming languages in ML. Advantages of Python in machine learning. Great library system, low entry fence, flexibility, platform independence, readability. Advantages of C# in machine learning. Much faster in most cases. A more clear and organized structure. The code is type safe. Advantages of JS in machine learning. JavaScript makes machine learning accessible to web and front-end developers. Cross-platform programming language. The most popular web development language with a major NPM ecosystem. Well, that's about it for this part. We've covered a lot of information. So, the best one for me is Python. It is machine learning royalty. Python has an enormous number of software choices for a machine learning programmer. NumPy, SciPy, TensorFlow, PyTorch, Apache Spark, Keras, and more. Because of this gold standing in machine learning, Python also has a wealth of videos, tutorials, and tried and true examples of function. Here is a quick recap of the main points of this presentation. The main goal and the relevance, analogues, dataset of the project, research methods, and research tools. That brings me to the end of my presentation. Thank you for your attention.